Okay, so in this video, we'll also be solving for the Z transform. In the first one, we check for Z transform, or we solve for the Z transform of a sequence. In this one, we would be looking at a sinusoidal signal. Okay, so in this case, our x of n is equal to 0.3 raised to the n power cosine of 0.46 pi of n, okay, times the unit step of n. And for us, n is going from 0 to 1 to 2, 3, so on and so forth, okay? All right, and again, we're trying to find the Z transform for this. So if you recall, the Z transform is equal to, from n being equal to negative infinity to infinity, of x of n z times z raised to the negative n power. Okay, so we know that this is our x of n here. Okay, so if you put this into our definition of the Z transform, then this becomes summation from n equals to 0 to infinity. And the reason why it's 0 to infinity is because we're using the unit step here. Okay, from 0 to infinity of 0.3 raised to the n power cosine times cosine 0.46 pi n, and again that's times z to the minus n power. Okay, now in order to figure this out, I would highly suggest that you use a Z transform table or a Z transform table. Okay, so take a minute to look at your Z transform table and see what you may turn this into in the Z domain. And so what you should have found then is that we can transform this to x of z is equal to 1 minus 0.3 times cosine of 0.46 pi, oops, pardon me, no n, because we're now in the Z domain, okay, pi z to the minus 1 divided by 1 minus 0.6 cosine of 0.46 pi z to the minus 1 plus 0.09 z to the minus 2. Okay, now if we look at this portion right here, okay, we may say that cosine of 0.46 pi is equal to 0.1253, which then gives us a result of x of z is equal to 1 minus 0.0376 z to the minus 1. So in other words, we're multiplying this times the 0.3 here, okay, which gives us this, okay, divided by 1 minus, and this is going to be 0.0752 z to the minus 1 plus 0.09 z to the minus 2, okay, and again this middle term here came from taking this and multiplying it by 0.6, okay, which ends up giving us again this term here. All right, so this is the Z transform of this sinusoidal signal here using again, we're using the transform table, Z transform table, in order to get there. Okay, so this is our answer for this one. All right. So again, please do check out my YouTube channel, and you should see some more videos on Z transform, both the transform and the inverse Z transform.